Class 8 Science Chapter 11 Force and Pressure, and in this video we will discuss about pressure. Before discussing, just look to this diagram. This represents nail, okay, and this part of the nail is known as head and this part is pointed end, okay. Now try to push a nail into a wooden plank by its head. Did you succeed? Definitely no. We are not able to push nail into the plank. Try now to push the nail by the pointed end. Did you succeed? Definitely yes, like this one. Okay. The same way, try cutting vegetables with a blunt knife and then with a sharp knife. Which is easier? Definitely with the sharp knife it is easier. We can conclude that area over which the force is applied plays a role in making these tasks easier. You can again see area of this pointed end in the nail is smaller compared to this one. In the same way, area of this sharp edge of the knife is smaller compared to this blunt edge of the knife. Now there is a relationship between area and pressure. Okay, we can say the force acting on a unit area of a surface is called pressure. You can say pressure is equal to force by area. From this formula we can say this is pressure is indirectly proportional to area. It means if area is smaller, pressure will be large. If area is large, pressure will be small. Okay. Area is in denominator in the above expression. So the smaller the area, larger the pressure on a surface for the same force. The area of the pointed end of the nail is much smaller than that of its head. Therefore, the lesser force produces a larger pressure, which is sufficient to push the pointed end of the nail into the wooden plank. Due to the same reason, the shoulder bags, okay, these type of bags which are hanging on the shoulder, and school bags like this one are provided with the broad strips. These are the broader. Okay, this is broader. Now broader means larger area. Larger area means pressure will be smaller. Okay, and tools meant for cutting and piercing always have sharp edge. Sharp edge means smaller area. When area is smaller, by the same force we can exert the more pressure. You can say this is scissor. These are the some tools which are using for cutting and piercing. Pressure exerted by liquids. First one activity is there. Take a transparent glass tube or a plastic pipe. Also take a rubber balloon. Fix the rubber balloon tightly over one end of the pipe like this one. This is the pipe and at this end we have fixed this rubber balloon. Hold the pipe at the middle, keeping it in a vertical position. This is called vertical position. Now pour some water in the pipe. Observe that rubber sheet bulge that is come out. This one, this part will come out. Okay. Pour some more water. Again observe that rubber sheet bulge out more. You can see as this we add the more water in this pipe and then this amount of bulge will increase. Okay. That's why whatever we are observing, as the height of the water column in the pipe increases, amount of the bulge in the rubber sheet or in the balloon also increases. That's why we can conclude pressure exerted by water at the bottom of the container depends on the height of its column. Now see one more activity. Take a discarded water or soft drink plastic bottle. Okay. Fix a cylindrical glass tube a few centimeters long near its bottom. This is a discarded water bottle and from bottom this is a one tube we have fixed. How can we fix this tube? This can be done by slightly heating one end of the glass tube and then quickly inserting it near the bottom of the bottle. Make sure that water does not leak from the joint. If there is any leakage, seal it with the molten wax. Cover the mouth of the glass tube with a rubber balloon. This part of this tube is covered with this balloon or any rubber sheet. Now fill the bottle up to half with water. You observe that rubber sheet fixed to the glass tube bulges out. Again same, this will come out. Pour some more water in bottle. Amount of bulge in the rubber sheet also increases. Okay, that's why we can, again you remember it in this, that this rubber tube is not at the bottom, this is in the side. Okay, that's why we can say water exerts pressure on the sides of the container. There is one more activity. Take an empty plastic bottle, drill 4 holes all around near the bottom of the bottle. Make sure that the holes are at the same height from the bottom. Now fill the bottle with water. You can see this diagram. This is bottle and these are the holes. This is okay at the same height. At the same height from the bottom. And when we fill the water, what we will observe, that is water comes out from these holes. And one thing again remember, that the distance of the stream is the same. The different streams of water coming out the holes fall at the same distance from the bottle. That's why we can say liquid exert equal pressure at the same depth. Finally, we can say liquids exert pressure on the walls of the container. This wall may be at the side or at the bottom. Now, pressure exerted by gases. When we inflate a balloon, inflate means fulana, we have to close its mouth. Okay. If we open the mouth, what will happen? If we open the mouth of an inflated balloon, it flattens. That is, air will pass out, air will escape and it flattens. If we have a balloon which has holes, we will not be able to inflate it, because whatever the air we are inserting it will pass out from these holes. That's why we can say air exert pressure in all directions. If there is a puncture in the bicycle tube, you are familiar, it flattens. Okay, you can say this is inflated bicycle tube, and when there is a puncture, this will come like this. This is inflated. We can say that air exerts pressure on the inner walls of an inflated balloon or a tube. And that's why air exerts pressure on the walls of their container. Atmospheric pressure. There is air all around us, and this envelope of air around us is known as atmosphere. And the pressure exerted by the air which is around us is known as atmospheric pressure. Atmospheric pressure is the force of gravity on air in a column of a unit area. You can assume that this is the unit area of this column, and this is the air. This is we can say this atmospheric pressure of this air is due to force of gravity on air in this column of unit area. Now, what is the magnitude of atmospheric pressure? There is again one activity. Take a good quality rubber sucker. I think you are familiar with this rubber sucker like this one. Okay, this. You can hang or you can stick this rubber sucker on the walls. Okay, this is also the rubber sucker. It looks like a small rubber cup. Press it hard on a smooth plain surface. And then you will observe that it sticks to the surface. This is one plain surface and this is a rubber sucker. We press hard. That's why it will stick to the surface. When you press the sucker, most of the air between its cup and the surface escapes out. The sucker sticks to the surface because the pressure of atmosphere acts on it. Now we can say that is in between this cup of sucker and in the surface. When we can stick half, when we press it hard, the air between these two will escape out, and that's why the atmospheric pressure is more, and this will apply on this. That's why we are not able to remove it easily. To pull the sucker off the surface, the applied force should be large enough to overcome the atmospheric pressure. Okay, this activity gives an idea about the magnitude of atmospheric pressure. Now you can see how large the atmospheric pressure is. You can explain. It would not be possible for any human being to pull the sucker off the surface if there were no air at all between the sucker and the surface. Now you can imagine what is the magnitude of atmospheric pressure. If the area of my head were 15 centimeter into 15 centimeter, how much force air will exert on my head? The force due to air in column of the height of the atmosphere and area 15 centimeter into 15 centimeter is nearly equal to the force of gravity on an object of mass 225 kilogram. You can say this is the force of gravity on my head. If we assume that area of my head is 15 centimeter into 15 centimeter, and actually this force of gravity will express in the Newton. Okay, when this kilogram is multiplied by the gravity force of gravity, that is 10 multiplied by 10, then we will get this one. You will discuss in the higher class, that is what is this Newton. Okay, simply assume that if there is a column of, or we can say the area of my head is this, then this much amount of force of gravity is on my head. Okay, the reason we are not crushed under this force of gravity is that the pressure inside our body is also equal to the atmospheric pressure and balances the pressure from outside. That's why our body will not crust. Okay student, thank you.